Alright, so now let's have a look at tutorial 4, question 3. So they say to you the steel ball in a viscometer is 2.5 millimeters in diameter. So the diameter is equal to 2.5 e minus 3 meters. And the specific gravity of the ball, so that's the density of the solid, is equal to 7,800 kilograms per cubic meter. They tell you to calculate the viscosity of the oil. So that viscosity is unknown. Okay, and the SG of the oil, so density of the fluid in which this ball is going, is 959 kilogram per cubic meter. All right, at terminal velocity, so that's ut, the ball falls, takes 10.3 seconds to fall through 250 millimeters. So it's 250 e minus 3 meters divided by 10.3 seconds, and that should give you your velocity in meters per second. And of course, here is the answer. So let's give this a shot. Let's go into Excel, and same as last time, we're going to set up our equations. So usually when there is something unknown and you know that it's lying in the middle of your equation, it's not worth it to rearrange all your formulae and things like that. But especially if you're working in Excel. If you're working on paper, then maybe it's a good idea to rearrange your formulae. But for now, because we're using Excel, we can afford to just put down our unknown variable first. So put down your unknown variable first, and let's just guess 0.001 Pascal seconds. And that's just to give Excel some kind of guess value to initiate the calculations. So we've got our mu down. Let's put in the diameter, 2.5 times 10 to the minus 3 meters. The rho of the solid is equal to 7,800 kilograms per cubic meter. The rho of the fluid is equal to 959 kilograms per cubic meter. And then the terminal velocity is equal to 250 e minus 3 divided by 10.3. And that's meter per second. All right, so we've got everything that we need. Let's begin. And all you're going to do is do the normal procedure. Calculate your Archimedes number, your Reynolds number, iteratively solve. And once you have that, you can calculate the difference in the iteration, and that will be you. And then we can use gold seed to change the difference in the iteration at varying mu values until we get to a zero difference. But if that doesn't make sense, then just keep watching. Okay, so we're going to proceed with our normal calculation. We're going to start with the Archimedes number. So that's 9.81 multiplied by the density of the fluid multiplied by the density of the solid minus the density of the fluid. And that entire thing is multiplied by diameter cubed. And we divide that by the viscosity squared. So remember, all of these values are correct here, except the mu value. So this Archimedes number is determined by my mu value. Next, I can calculate Archimedes over 18. So it's equal to this cell divided by 18. And it's actually a very big number. So what you can say here is that, what you can say is that Archimedes number is equal to 1,005,605. So that's my Archimedes number. So Archimedes number divided by 18 is equal to 55,866, which is definitely bigger than 0.2. So that implies that we are not in laminar flow regime. Okay, and because we're not in laminar flow regime, we'll have to use this equation. Archimedes number is equal to 18 Reynolds number for the particle plus 2.7 Reynolds number of the particle to the power of 1.68. So we will have to use this equation because we are not in laminar flow. So I will quickly just work out the Reynolds number of the particle, and that will be equal to the diameter times the velocity times the density of the fluid. Very important to keep that in mind. And you divide that by the viscosity, which is actually unknown. So I'll go down here and say that my Reynolds number of the particle is equal to diameter, terminal settling velocity, density of the fluid divided by mu. And it's always nice to write down the equations you're using. Okay. Now I can set up my iterative equation. So I'm going to say the left-hand side is just equal to the Archimedes number. The right-hand side is equal to 18 times the Reynolds number plus 2.7 times the Reynolds number to the power of 1.68. 18 plus 2.7. Okay. And my difference is then equal to the left-hand side minus the right-hand side. Okay. So you can see that this difference is very far from 0. So I'm going to open up the goal seek and say, okay, I would like you to set this difference to be 0. And I would like you to do that because all my other values are correct except the mu value. So can you please change the mu value so that this difference is equal to 0. So I'll say okay, let it do its thing, and my answer is pretty close to 0, and my mu value is 0.939. So that is my final answer. Let's go up, and you can see it's pretty close to 0.9601. And so my final answer is that mu is equal to 0.939 pascal seconds. All right, I hope you found this helpful.